Let's get started with some company update.
Uh, Tinybox V2s are shipping. I think we're going to be all caught up this week, which means if you order them, they are going to ship out right away. So that's good. AMD contract signed. Work started on that. Yeah, I think that's pretty much it. We did very well in our beef with Etched this weekend. The latest in fake AI startups. I've been getting DMs from people about the Etched thing. It's way worse than you think it is. They've never taped out a chip. I guess this isn't related to us, but I can't believe. The more you work on this.
For the audience in this meeting that's not aware of it, you have I give you 3 minutes to go through this.
Okay. Yeah, so Etched is this company that's claiming they're going to tape out some chip that is a transformer ASIC, which gets 20x performance over H100s. But this is nonsense. 70% of time and power spent on transformers is just spent in GEM, and GPUs are already pretty close to ideal GEM machines. I did learn something really interesting. So apparently their plan was a 2048 by 2048 systolic array. Just make a huge systolic array, and then you could basically calculate one transformer. But this doesn't work. ChatGPT did this whole analysis on it, and it says basically the ideal size for a systolic array is 128 by 128 because you have losses in the wires. You don't want to make wires really, really, really long, right? And think about why. If you make a really, really long wire, that wire is going to have capacitance. And then you have to use more power to drive that wire. So yeah, the whole plan is utterly nonsense. I'm happy we debunked them on Twitter. So that's that situation. And GPUs are already really close to optimal. So another point in us not making our own chip anytime soon.
I see.
But yeah, no, it's very AMD is very exciting. I think that AMD is really going to be brought on par with Nvidia in a couple years, and then yeah, we're in a much more of a commodity landscape.
Oh, have we received the new machine?
We've not received the new machine, and we haven't gotten paid yet. But I don't know. These things just take a long time. Technically, they have 3 months to pay us or whatever. It's not that we need the money. And no new machine, but it's not that different from the old machine. I'm pretty sure the warp size is still 64 on CDNA 4. Yeah, okay, then nothing really changed.
Uh-huh. Okay. We sell. Do we have Tinybox Red V2? And
Whoa, Red V2. I haven't heard anything about that. We have Tinybox Red. We have to sell Tinybox Red. We have two more Tinybox.
22.
We have to sell the Tinybox Red first. I'm not going to make V2 if we haven't sold all the Reds. I have 2 of them just sitting there still.
Okay.
The government bought 2 of them after a long ordeal. We still
You'll come back and buy another 2?
Yeah, maybe in another 17 business months, yeah.
Great. Okay. Sounds good. Okay. I don't know what to call your stuff, but your stuff is next.
Yeah, so I did a lot of reading last week on. So Halide is the good one of these. MLIR seems to be this ecosystem of big team 500 line things to express one rewrite rule kind of stuff. Then TVM started with Halide, but the main problem I've seen with TVM is they've just added everything to it. TVM can interface with everything, and when you try to do everything, you get nothing. But Halide is the OG good one, and they've basically broken down all types of optimizations into Pretty much 4 types. 2.5 of which we have. There's one that we don't really talk about, and the one that we don't talk about is like when you want to do recomputation. So Halide has a good language for that, and we can kind of move to it. But what I realized reading all this stuff is that we've massively overcomplicated like what's really a very simple optimization space now, and I'm just working through all the refactors required to expose that simplicity. Also, fixing the lower fixes all of these fusion things. Like, you want to use, every time there's a reduce, that reduce basically creates ranges. You don't want to try to reuse ranges that already exist somewhere. And then you can think about doing range fusion later on. It's a lot easier to do fusion than it is to do splitting. Because if you think about it, like, if you want to split something into 2, you have to look at children. If you want to take things that are already 2 and just make them 1, we'll just replace all instances of 1 to be the other. And that's like an easy operation. So yeah, we'll generate the reduces with all the ranges. Every reduce that's created gets a new range, and then we can think about range fusion later. And then we can specify unrolls on each one of those ranges completely separately. And this just like fixes all of that weird stuff about multi-reduces and yeah. But the thing that I really want to get in that's still going to require a bunch of refactors is removing keep dims from the reduces. The reduce should remove the reduced dimensions. It should not leave ones. Dimensions with ones are total nonsense and should be removed from everything. They do nothing. You don't need them. So, working toward that. It's gonna take.
Yeah, what's the plan for all the full shape and all those permute and reshape in kernel?
So full shape is also nonsense. You can't have full shape because if you have a parallel multi-reduce over different size dimensions, like that thing that causes the trouble with the thing that makes the A-range fuser way too complicated, there's no such thing as a full shape. You can have things with different.
I understand.
Yeah.
But there's code in kernels and there's some other logic that requires that now.
Well, yeah. I mean, okay, so I took a big thing out of the lowerer already. The GPU dimensions have been refactored out of the lowerer. But the thing that I haven't refactored out of kernel yet is the tensor cores. And that's until we do that, it's really hard to delete kernel. So that involves upcasted warps. But I don't know. I'm just going to leave all this. I think we can get flash attention without any of this, and I think we can get fast gem without any of this. So, like, to keep this project scoped in something that's concrete, my goal is at the end of like a month or 2 to have a really fast gem and a really fast flash attention on the MI300.
That sounds good.
And I think we can leave the full shape stuff. I think it's not that bad.
Just hard to replace with something else.
Well, yeah, and we can also just like not optimize in that case. You don't actually need kernel.py. If kernel.py detects this weird case, you can just say don't use it.
You know what happened to Halide? It seems to be pretty active still. Do people use it now?
So, I had lots of conversations with ChatGPT about this. ML stuff is not using Halide. And there's a few problems mostly with its implementation, such that an ecosystem didn't sort of form around it. So, like, for example, Halide only supports 5 dimensions. It's like, it's not a real limitation. It just happens to be the way the thing's written. The thing is written so much with, like, this idea of image processing. The buffer is even called image. People just didn't like that. So a lot of the ML stuff moved to places where there were these ecosystems. Like MLIR is an ecosystem and TVM is an ecosystem. And yeah, so that's why people don't really use it.
Because on their README GitHub page, it also says it supports like CUDA, OpenCL, Metal, Qualcomm, basically the things that we support or we want to support?
So it does. It supports metal. I got it outputting metal stuff. You can definitely output all this stuff. GPUs were a bit more of an afterthought. They added on like a bunch of kind of hacky things to the optimization language. It's clear that it's all designed for CPUs.
I see.
It's also missing a like a good. It doesn't have anything like our memory scheduler. So it's not that good with like this idea of multi-kernel memory scheduling. That's something that like TVM has and that we have. And actually, they don't really support Qualcomm. Their Qualcomm support is all out of tree, same as ours.
Yeah.
Because of the complexity of Qualcomm. But like the Halide PhD is really good. Like it's super readable and it explains clearly this like it has this like triangle that says basically you have a choice between I'll get the triangle. I posted it in the theory channel. Parallelism, locality, and redundant work. And you have to do trade-offs in that. Right? So like it's easy if you don't care about doing lots and lots of redundant work, okay, it's trivial to make everything parallel and local. But then you're like, well, but I don't want to do all that redundant work. Okay, but now what are you going to do? Save that? Okay, that limits locality. If you're okay with no parallelism, sure, you can get perfect locality with no redundant work. Just do everything locally.
Mm. Where is this person now?
Oh, the Halide person? He
Okay.
works at Adobe.
Oh, I
Writing.
see. That's why Adobe and Google are the only two big companies that use AI.
Yeah, I mean, yeah, he was at Google and then he moved to Adobe.
I see.
A lot of the Photoshop tools are written in Halide.
Great. Okay.
Yeah.
Sounds good. Okay, let's move on. I want to quickly think. So we delete some tests that was written with like a very hard code UOP style that's very hard to update. Since now we are refactoring again and changing lots of stuff. There are still more. Do we want to just remove them all, or we remove once it blocks stuff?
I'm
Any
mostly okay with deleting it. I don't think we really have to do it proactively. I think, but once these tests are failing, I think it's better to just delete them, and we shouldn't be writing tests that like hard code huge UP strings that are copy and pasted.
Kernel data set is another thing. I remove like 90% of the stuff in that script. It runs like under 2 minutes on my machine, so hopefully that's a lot better now. I don't really want to change that, but some scripts relying on a data set that works. So fine
I
this.
think we should put the generation of it in CI, and you can just download it from CI.
Yeah, that's probably better. One
It
more
doesn't have
worker.
to auto update or anything, but yeah, just add another worker that does that.
Okay, I can do that. Cool. So Llama 405B, I added some more stuff. I think the training loop for AB is pretty much there. The only bottleneck, the main bottleneck now is running this with a context length of A192 calls out of memory. And I don't know when we compute how many what the VRAM we need. Do we include anything that we need to save for the backward from like, running with the sequence? Like the activation or any intermediate thing that requires us to store it for the backward.
We'll
Because
have to.
there's
I mean, we have
there's
to use the
certainly
tool. Look, I don't know.
yeah, because there are certainly stuff that we compute in the forward as a function of your input length. That's why like input length with 3,000 works, but 8,000 doesn't work.
Yeah, we got to just make the tooling for this better so we can see it easily.
Yeah, and so I wanted to either understand that better, or I started to add like sharding. So since AB works in one GPU, I would expect like 70B to work with 8 GPU. And I was testing like sharding 8 on 2, and bad thing happened. So I probably need to read this FSDP, or is it like different kinds of parallelism?
So, before we think about sharding, does it work with fuse optim?
I think it used a lot more memory. Less
Yeah,
memory.
okay, we have to fix that first. So what FSDP is like you
I thought
can
it's
do
less of
fuse.
an issue because eventually we will put the optimization stuff all on CPU.
Well, yeah, but we have to do fuse optim first.
Oh, I see. Why is that the case?
Because you
Is that
when you're doing that
CPU?
copy,
Uh-huh.
you don't want to. The optimizer update should really just be one thing. I guess you in theory could do each one on the CPU and like copy each thing. Oh, no, I know
Yeah,
what it is. Yeah, I guess
okay.
if it's all on the CPU, then maybe it's actually okay.
Yeah,
But if you
that was the main reason I thought about it, and I was like, okay, maybe we don't need any of the optimizer sharding stuff because it's on CPU.
Yeah, maybe we don't actually. Yeah, I mean, so this would just be for sharding the M and the V. Uh, we have to make sure that the gradients are only on the GPU that has the sharded, that has the weights. Or at least the gradients are sharded in the same way the weights are. I don't know if that works.
Yeah, I think that's the idea, but now there are like stuff that I don't know.
I mean,
Yeah,
we also have to choose
I
which
think I
kind of
think we need to
sharding.
worry more. I think we need to worry more about the intermediate buffer that's required for backward, and also the gradient more than the MMV. That's my point.
Yeah, that's probably true.
Yep. Yeah. So next goal for me is to make 70B sharding works. I think this requires understand memory because I was naively trying Sharp 2. And instead of one GPU using 50% of the memory, now I have two GPUs both using 90% of the memory, and I don't know why.
Yeah. Well, I mean, I think we all sort of have a I think we all sort of have a job to do for Llama 405B.
Yeah.
Uh yeah, I mean, you're on the
My plan
ML
is
Pro.
gradually adding features so we can work with bigger and bigger models with more and more pieces that we will need eventually for our 405B training in the script.
Can we train 8B according to the rules?
So A192 doesn't work. So that's the immediate blocker. I cannot even run
Okay. Can we
with the
train
full.
8B with 2048 or something?
Oh yeah, I think so.
Yeah, I think we should do that. I think we should just like start getting runs going and then start pushing these things up.
Need to learn how to pad the inputs properly.
Yeah.
Well,
Yeah.
one annoying thing for 405B is there's no reference. There's no real reference implementation. Just throw you like a Nemo link and say install Nemo, and what it runs is a reference.
Wait. But yeah, but that stuff's got to be open source, right?
It's open source, but it's like reading Torch. So
I
okay,
see.
you want your optimizer. Okay, it's an abstraction layer of stream Adam W put inside that, and go figure who codes will create this.
Yeah. But
I would
getting
go
right.
with that.
I promise you that every single batch is the same. There's nothing with variable lengths at train time of any of these
Yeah.
LLMs.
No, so they use variable, but it's not like changes for every example. They use different lengths for training. For original llama, not for MLPerf.
Yeah, there's no way. There's no way that anyone's doing variable lengths for any modern LLM training.
Are they doing
It's just
sequence packing?
I don't know what that is.
yeah.
If you have like a shorter sequence, you just throw another one on and you change the attention mask.
Yeah, I think that's right. Yeah. Oh, you say they changed the mask so it can't pay attention to the old one.
Yes.
Oh, that seems plausible.
Okay, I don't know. If was Perry, you think you are better at figuring out what is really being used, I can work with you later.
I'll take a look. Yeah.
I was struggling with reading Nemo, like reading Torch. It's a same vibe.
Yeah.
But on the better side, anything I put in a script, I have a reference link. I'm pretty sure that's what's being used. I don't think we'll be challenged once we submit it wrong. So there's that.
Great.
Okay, with that said, let's move on to this.
Immerse the memory graph. So you can try it out as a master. And yeah, I'm gonna work on just a way to go from like a buffer to the actual kernel, to the actual node in the kernel graph. So you can see clearly like which buffer it's hold on to and why. I tried Llama, and it looks like the graph just grows and it's allocated 24 gigabytes. So I think
When
we're
you say you
holding on
tried Llama, what was the thing you tried?
just the script that you merged for the ML per model train.
Llama training.
Yeah.
So by default, it runs a A/B model, and that certainly doesn't fit for a single 24 gig GPU.
Yeah, it's out of memories.
Yeah, so if you want to try on the regular tiny box, you can change the llama size to 1B, and that would fit. And I believe give you similar patterns in terms of training and parameters stuff. And if
This
you
should
want,
also it should all work with the null backend too, right?
Exactly. I was gonna say that it
yeah,
works
for
completely
that.
fine with the null backend, and you see it allocates 100 gigs, and it goes down eventually. But we need to figure out why it grows so much. Like everything, like the entire pattern is completely clear. So
Yeah, so I think one thing will be really interested, not necessarily llama, but so we talk a lot about like the buffers we stores in the forward so that it's needed for backwards, and if the viz tools can show like what's being stored in the forward that's later used in the backward, that will be useful.
let's see. So do you want to see like the UOP or the actual kernel?
Uh, I'm not exactly sure, but it's more of, so we always worry about, are we saving too much stuff? Like for the activation, we might in some case store both the input to the activation and the output. But you can imagine we only need to store input. If we really want output, we can recompute. So to make these decisions, we want to first understand what's the current behavior, and it would be useful to know like what buffers are we store even if we already reach the loss and start to do the backward. The long edges between your thing before your loss and after your loss.
Let's see. Okay, I'm thinking like maybe we can have a line number location, like kind of like metadata for the buffers. This is
I think
the
the challenge part is there's no really a line for backward, because backward is kind of derived from the rewrite rules.
I think you can backtrack it. But I'll see.
Okay, I don't know. Yeah, so the use case I have in mind is I'm training a model, and for example, I know the model is say 2 gigs, and I know the gradient of that is another 2 gigs, but now I'm seeing the max RAM I was using was 8 gig. So which means I use 4 gig more other than the parameter and its gradient, and I would like to know what happened, like what caused those 4 gig, because that's the first step I can decide if something is wrong in my script that I can remove and don't necessarily need to use that 4 gig. Okay. Anything else?
Yeah, I think we can get to a bunch of like rewrite rules here that are aware of the length of that edge. There's all sorts of things where I'm sure we're saving more than we have to. And again, we're on that. This is the trade-off between recomputation and locality. And Tinygrad is definitely opposed to recomputation. But this is costing us locality, and that's what's all the RAM usage, I think. So I think once we have a good way to visualize it, we'll be able to see what the rules we need are and then add them.
Yeah, I think we first need to tell certain behaviors happening before we can decide like what to do with those behaviors.
Agreed, yeah.
Cool. Okay. Let's move on to drivers.
Yeah, so for the USB GPU, I'll take a comment and share the repo link. Or yeah. So for NV, so I merged it last week. So we should have 4090 working without driver. So the performance is not great right now, but yeah, I'll work on this week and 5090 as well.
Are you sure the only problem is the huge pages?
Yeah. I mean, performance is not that bad. Like it's not really bad. It's bad, but not really. Mostly we have a lot of problems with Python because of we use small pages, and because of that we should allocate more. So yeah, it takes a lot of Python time.
So
So
you're talking about huge pages on the GPU side, like putting huge pages in
Yeah.
the page table on the GPU. Okay.
Yeah.
Does AMD have this or only NVIDIA?
Oh, we support this on AMD.
I see. So we have it on AMD, we just don't have it on NVIDIA.
Yeah.
Makes sense. Yeah, so I think not quite yet, but what I see kind of, so I think there's wrapping up this NVIDIA project, there's that COVID support, but then the big project I see you working on pretty much for the rest of the year is just going to be MI300X, whatever we can do to get more performance from it, better scheduling of the transfers, yeah, all that kind of stuff.
Weight.
Once we what?
Also weight, moving weights.
Yeah, like moving weights more optimally, and then also maybe potentially doing the AQL thing or figuring out what we're gonna do about the XCD sync. Yeah, just like moving weights from drives, figuring out why that's slow, being able to like, yeah, just figuring out what the fastest ways to schedule these things are.
Yeah.
But yeah, I mean, hopefully this is a place where our driver can really start to shine. And we can decide also if we want to bypass AMD GPU for the MI300 or not. Does it look pretty? Have you looked at all? Does it look similar, or does it look?
Yeah, I mean it's similar. The only thing which like it will be. So the only thing that is missing is that we need to like add 4 loops, because like XCDs it's like different GPUs, and they also set up like different GPUs. So we just need to add this logic. Otherwise, JFX9 is similar. Yeah, I mean it's pretty similar to what
I
we
think
have right now.
I think this will just come down to wherever we can get, just to follow the performance gradient wherever we can improve performance. I mean, yeah, pretty much our whole goal as a company for the next year is going to be to get maximum performance out of this MLPerf thing, and that's kind of it. If we can do large LLM training as fast as NVIDIA can, that's the biggest demand application now. But yeah, I mean, I like the idea of first getting the MVPCI project wrapped up and making sure that the abstractions we're working with are capable of. I think you can choose whether you want to prioritize the video decoder stuff or whether you think there's stuff that we could start doing in the AMD stuff earlier.
By the way, I saw you fix the SDMA overrun issue. What was that?
Basically we couldn't so we have yeah, it seems like we generate a lot of copy comments right now, and we simply didn't have any logic to just kind of wait until everything is processed in this queue. So yeah, I mean it's but basically in short, like we had more comments than the queue size, and yeah, because of that we just cannot fit all of them. So now we just can wait for this.
Yeah, I mean, I see the spin weight that was added.
Yeah, I mean, actually, I think that's I don't really like that, because maybe we should, I don't know if it's a bad idea to have like environment variables again to set the queue sizes, but I think, yeah, we should not stall there and waiting for a queue. Like,
How big is the queue right now?
16 mix.
Could we make it bigger?
Yeah, sure.
I mean, is this something where if we make it 32 megs, it's fixed, or if we make it 32 megs, it's just a bigger problem?
No, I mean it's fixed for the current workload, but generally I think we can have the same problem, like training
Yeah.
maybe lamb or something. Yeah.
Yeah, I mean, I see, line 409, which is doing the spin weight, and I just see that. I see it getting stuck there, and then that becoming really hard to debug.
Yeah, and also yeah. Oh yeah, maybe it would be a good idea to add timeouts there. But also the problem is also only with its DMAQ, because we do not support like indirect comments on only on AMD's SDMAQ. So yeah, and because of that, I just can overrun, and not all other queues, because they like launched in the indirect manner.
Sounds like we should just
We
make it
should,
bigger.
yeah.
I mean, basically for me, because I will be running a bunch of testing smaller model training stuff. So I will keep posting in the channel for any issues that I had. Do let me know if you want me to run some other diagnosis scripts in case anything bad happened. For now I just look at the message and post what's there.
Yeah, basically that's all the information we can currently collect. Yeah.
Sounds good. Okay. Anything else?
No.
Okay. Let's move on to Cloud, Tiny FS.
Not much for me this week. I was out last week. This week, I would just try to get TinyFS merged. That's kind of the goal for this week. I guess if UVN has anything. But
I
don't
upload
think.
llama weight.
Llama weight.
We should be able to start fetching the llama weight from the
Oh yeah.
file system, right?
I don't know. The big one is pretty big, so I don't know.
Big one's pretty big.
Maybe at least using that to run like a llama 1B or
So is it all solved? Like, what side's going to do the hashing? And
Yeah. And we don't want the client side to do the hashing. So.
cool. Yeah, our big first milestone for this is getting is moving. We have 2 provisioning machines now.
We
And
already
we
moved
want
so much stuff off of those.
I want to. Yeah, no more of those.
They're just RAID boxes now.
Yep. Oh, you've already moved everything to the gateways, or to
Yeah,
Pixie.
Basically, everything else is just off those or on the provisioning OS. Those are just RAID boxes now.
Great. Let's get rid of them. They're ugly in that room.
So we have 2 more Redbox to sell.
Oh no, they're not red boxes. In fact, one of them is the only blue box we have. We have one of them is a blue box, and one of them has 2 broken 4090s in it.
I don't know. Maybe they are using their last strip of value.
Yeah.
Okay.
Yeah. Does anyone want a blue box custom one-off? No, we never sell custom one-off things. You guys are gonna post and complain.
Okay. Okay, that sounds good. Next. Z3 symbolic or anything else like us you are working on? Hello.
We can't hear you if you're talking.
Hi, can you hear me now?
Yes.
Yes. Okay, so yeah, so this week I've been working mostly on the view cons refactor. But I had some PRs last week that were from the new fuzzer. It's like fuzzing individual rewrite rules. And I mean, I have something that works. I just want to make it like into a nice tool that's easy to use if you have a new rule you want to try. And also I switched, and for fuzzing individual rules, I switched to like a bit vector fuzzer, which is a bit slower, but it also tests for like overflow, and also the div and the mod is a bit nicer because it's closer to like the Z3 bit vector div is actually like truncating the vision. So that's nice.
How much slower is bit vector versus the like int symbolic algebra stuff?
Well, so the problem with the bit vector stuff is that it scales very poorly with the size of your variable. So like one of your leaves in your expression is going to be some kind of like defined var or whatever. And if that defined var is quite small, then like it's only a few bits basically, then it's very fast, or it's almost equally as fast. But if you get something that's it gets exponentially slower with the size of your defined var. So if you want to put in 32 bits, that gets quite slow. Whereas the integer stuff does like, scales really well. Just the integer stuff scales with your amount of constraints.
Yeah, that makes sense. I mean, my dream is eventually to like move this away from an SMT solver like Z3 and to like a SAT solver like PicoSat and do the lowering in TinyGrad.
Yeah, I mean with the bit vector stuff you can do that.
Yeah. Like we have basically, I don't think we ever have to write a sat solver. I think that's ridiculous. But if we switch to, I do think it might be worth writing the basically the definitions of what each of these things are, right? Because we have these things now. It's like add. Well, what does add mean? We can actually expand that into a bunch of Boolean operations in a graph.
Yeah.
That should be linear in the or maybe squared for multiply.
Doing that for division though might be painful, but yeah, I mean
It's
that's basically what it's doing, yeah. Or at least for the bit vector stuff, basically it's what it's doing.
right. Like, but Z3 is doing this somewhere under the hood. I don't know how to write a divider. I don't know how to write a divider in terms of Boolean logic. But if it's a divider by like a fixed number, I'm sure that's pretty easy and all that kind of stuff. So yeah, it'd be cool to have rewrite rules that can rewrite everything into D-type bool.
Yeah.
Yeah. I don't know. I don't know how useful that is as a project, but I'm definitely interested in it.
I mean, where would you use that?
Well, so
like for that checking, like I mean, also that would get slower.
I mean, we'd use it for two things. So there's a whole. We wouldn't actually use it to render things. We could use it for verification, but then we could also use it to render to FPGA backends. Like we could render the whole. We could render a neural network into Boolean logic. I was talking with some guy on Twitter about this, about how basically like as these D types become like what is FP4? It's almost easier to write FP4 as Boolean logic than it is to write it as anything else. Yeah, and then to like re-extract from the Boolean logic what the system is. I don't know. Just it's an interesting place that we can lower and raise from.
Yeah.
Specifically for the view const thing, I saw Crosling has lock bounty and reply to in that PR already, so I would refer to her to handle that.
Yeah. Just the one thing I got from that is that it's fine that there's no more const folding in the big graph, right?
Wait, why is there no const folding in the big graph?
Because you pass
Well-
CVAR doesn't match, right?
Wait, huh?
Which I mean, all the rules, like all the symbolic rules, they have upath.cvar, which matches either a const or match a const. But if you have a const with a view on top,
well, yeah, but what should happen? No, it should still work. Okay, so what should happen is this: const. If I added a rule to st, whereas const on a shape has
Ask.
const on device has a shape of 0 dimensions. So there should definitely still be.
sorry, I can't hear you.
Oh,
So just
can you hear me now?
yeah, you're just cutting out sometimes. I don't know if it's me.
So there definitely should still be const folding on the big graph. And the way that it should work is you want to move the views right? So a const has a shape of a 0 dimensional, just like an empty tuple. If you have an empty tuple, like there shouldn't be a view. There doesn't always have to be a view on a const. There only has to be a view on a const if it has a shape, if it's expanded. But if you have two consts that are added together, the views should move right across that add. And we might have to add that view moving right to the big graph. But we absolutely still need constant folding in the big graph. Do you see what I mean? How to do it?
Yeah. The only time you can't do it is padded, but yeah.
Yeah. I mean, it's not. Look, if we don't have it, it's not the end of the world. But We should definitely be able to add it back by moving views right and having the default shape of a const be bracket bracket.
Yeah, okay, I'll try that.
Cool. Yeah, just move the view. If you have a binary op which has two identical views on it that are expansive views, those views should be moved right. That's a universal rule. Same thing with a unary op. Yeah, if you have expansions before the op, then they should move right.
Well, if you have like x plus 1 and x is a load, or even if x isn't an expansion, then you still move the 1 or the x plus 0, because you want to fold the 0. But
well, zero can always just go away. And oh, I see. So you're saying like, what do you do about the plus 0? Because there's a view there that's doing an expand. Yeah.
if there's no math, then the shape can just be kind of whatever.
Well, the shape has to be a real shape. I mean, it does have to match. Yeah, I guess the plus 0 is a different case from the const folding. But for like the const folding for like 1 plus 2, it should move the views right and then do the const fold using the normal rule.
Yeah, that should be easy to get back.
Yeah, I mean, it's not like const folding is a lot of rules. I don't know, but I'm not.
There was some problem like if. No, it's fine. Yeah, I can do that.
Yeah, but if you want to take it out for now, I'm okay with taking it out.
Let's just try to be practical and not to be blocked too much by some of the rarely seen in real life test cases. If you think it's like not necessarily fine to remove, but do think about it and think about like what needs to be done if you want to like support it later.
Yeah.
Anything else?
No, it's good. Thanks.
Okay. Let's move on to our next. So our next, we merge. I forget if it's this week or last week. We merge all the refactoring stuff on D type. So now the flow 16 is correctly parsed as flow 16, and the D type fallback is also merged. So the current situation is we have the previous OpenPilot test. Previously, we were using Flow32 for the model and Flow32 for input data. And now the behavior is we use Flow16 for the model and Flow32 for the data. Because for Flow16 model, Flow16 data, there's just weird mismatch compared to Onyx runtime. Some numerical issue, not like doesn't like the model is wrong, but it's just if it's bigger. So I think that's fine for now. The other issue that was brought out many times was the test flakiness. Not clear why.
Yeah, if you want to load the whole model, if you're sure it's fixed by something like moving the whole model to like CPU or Python, that's fine. And let's just get that fixed. That shouldn't make it much slower. Might even make it faster.
There was a draft PR on this. I think it's slightly slower, but if it's not too much. I think using Python is fine.
Yeah.
Yeah, CPU is less recommend because CPU might have more refactors down the line. Okay, I mean,
basically,
as long
whether
as,
it's CPU or
as
Python.
long as you can first reproduce this fairly consistently, then you propose a fix that looks fine, and you fix the scenario you reproduce, then I think it's good. George, you were saying something?
No, yeah, basically the same.
Okay. Let's move on to local.
Hi. Three things for me. First is that I rebased the PR to a cleaner approach after all the refactors that have been taking place in kernel.py, and realized on that. Secondly, I opened a PR to fix the gate on group store, because I think I explained in the PR, but I think the gating is pretty aggressive on locals, and it's not general enough to work on locals. So yeah, basically gating the gate pushing only for group stores right now. And also I started the refactor for yellow before red, and feedback on that one is.
Yeah, I see the use order dict. Why not just use kernel info, right? Like kernel info is the right place to track this stuff. Every time we do a transformation, it's bad.
Transformation of what?
Right. So the thing that we're eventually returning from the kernel class is this data class called kernel info. And can we just use kernel info to track everything?
Well, okay, I see.
So eventually where I see this going is that all of the information about the opt-ops is contained in kernel info. And then kernel info is this arg on the sink, which contains all the stuff that tells the lowerer how to actually do the optimizations. I could also see that kernel info being put on contiguouses, and that will let us specify from the top level tensor graph how to actually do stuff. But yeah, the yellows thing, it needs to be a simplification. If it ends up being more lines, we don't want to do it.
Yeah, I agree. But it's I think it's multi-stage, because it's address like many things at the same time. So yeah, in the end, I think it will be much more readable, I think. But yeah,
Sounds good. Yeah. But yeah, what I would do instead of this order dict thing is just create the kernel info in
yeah, but okay.
Yeah, and just
What I
mean,
tried
right?
before was to save the order dict as a tuple for the kernel info.
How you save it in kernel info, but I see you have global local reduce upcast. You can just have have 4 properties on that class. We already have most of them.
I know that for now I tried to left everything as it was before, and only add this thing in order to make all the offset calculations more straightforward. But yeah, that's like right now the offset calculations are like for each one of the different axes, it's like a different algorithm, different way of calculating the offset and the count. So
No, yeah, I agree. I agree that it's ridiculous, but I look at like things in your refactor, like line 139 and line 142, where you have properties that are returning these self-access things.
No, that I only add them in order to not have to change the test and the heuristics in this PR. I agree this like only to keep the changes in kernel.py. These are going to
Yeah.
to be
But where
refactored
I would go with this is like eventually what's going to happen with kernel.py, like don't add new code to kernel.py. Like adding a new thing called an ordered dict is not what we want to do. Kernel.py is eventually going to basically become kernel info. Like there's going to be some function that transforms your opt-ops into a kernel info. And that function can be a beam search, that function can be a heuristic, that function can be anything. That function could just be a straight up parser of a bunch of opt-ops. But yeah, like the closer we can get kernel.py, the more logic we can basically copy from kernel.py into kernel info, the better.
Okay.
I mean, I could see a world where get optimized AST just literally sticks the kernel info on the sink. It's just self.ast.replace arg equals kernel info.
That's very cool. You can just change some stuff in the kernel info, and hopefully lower will work.
Yeah, and no, but the best part is going to be when you can do contiguous. We have to unify contiguous and G-barrier, but once we unify contiguous and G-barrier, you'll just be able to do dot contiguous or dot contiguous backward with the kernel info at the highest level, and then that kernel info will propagate all the way down. It'll go through the scheduler, and it'll propagate to the lower, where it actually applies those optimizations, and that looks a lot like how Halide does it.
Cool. Okay. Let's go through other bounties, rapid fire style, starting with RetinaNet.
Not a whole lot of updates. I think I'm pretty much done with the rewrite. I'm just going to do the correctness check. I think kind of said that last time, but that's yeah, still in progress on that part.
Is it faster?
I haven't done the full run yet because I was just doing the correctness check still. I still have one line I have to rewrite. It's like an arc sort, I think at the very end that the original script does. So I just need to make sure that that's correct.
You can use our sort now.
Okay.
I don't know if it's faster, but at least it's Tinycorp, and you can complain more in Tinycorp.
Okay.
Okay, cool. I don't see you again here. There are a bunch of discussion on the cloud sync stuff. So I trust George or Words Parrot. Someone knows the stuff. Refactors. I think it's mostly pick. It's yeah. I mean, people are working on refactors. I don't know. Well, refactor bounties, they are hard.
I locked the const one for SLikeys.
Yeah, that one is locked.
The contiguous G barrier one should be pretty easy too. If someone here wants to look at one, moving the eldons before the red dims is pretty hard. The unifying the load store thing is super hard. Merging assign store should be a bunch of PRs that migrate assign to store. Yeah.
I think
And then
one difficult part for this is like figuring out the correct order to do stuff, and if need to split into multiple.
yeah. If someone's interested here in trying a refactor bounty, the contiguous G barrier one is very doable.
Why is the barrier not the contiguous to start with?
It was just easier to It was just easier to make it a different op, just so they wouldn't interfere, and I could add it as a separate thing.
I guess that's fine. Okay.
Like, yeah, we have a bunch of legacy rules for that. And the merging assign into store, I would start with, I will lock the bounty for someone if they can do, the first thing to do is to replace assign in the tensor.py level with store, and then to replace the things in the scheduler with store. You can do that. That part should be pretty easy. The hard part is going to be dealing with like C-style. C-style is has a different semantics for assign and store. That's going to be more annoying.
How are you gonna gate these stores? It's on the index.
Pardon me?
The gated assign. That's what we're gonna end up with.
What's gated assign?
For gated stores.
What's a gated store? You mean with an if statement, or you mean with an index that has a mask?
If statements.
Oh yeah, I mean that's if the if statements are just wrong. The if statement shouldn't be if. I don't. Yeah. Yeah, that's annoying. Everything that's in like the C style level and that level, it's going to be really annoying to unify, assign, and store. But you should be able to pretty easily do the top level one at kernel.py. Sorry, tensor.py and the scheduler.
There are those refactors. Finally, SVD and CFAR Torch backend. George, can you test these two? Like them both. I think it looks fine. If it looks fine to you, I think it's okay.
Great. Yeah, I can test them if you want today.
Just test it, and if it's fine, I think we can conclude these two. It's not our top priority, but the work is done. It's not too big for us to maintain anyway.
Oh, the guide one. Okay, did that finally come through?
Which one?
I feel like I tried it and it didn't work, but I'll try it again.
Yeah, so both of those have recent updates. I think that's the only kind of the author was keeping like merge master into their branch ones. It was probably harmless.
I see. And then the SVD one. Oh, good. There's some benchmarks. Are they reasonable? Oh, they're insane.
Oh, the code has lots of I's and A range and stuff in it, but
Yeah.
it's a glorified example, if anything.
It's something. Yeah, I'm okay with that.
Yeah. So just take a quick look to see if there's anything obviously wrong. Otherwise, I think it's fine to let them.
Will do.
Okay, that's it for this meeting. Thank you, everyone, and we'll see you next week.
Bye.